Hello everyone, and welcome to reInvent, and welcome to our session on compute innovation using the AWS Nitro System. My name is Sudeep Sharma. I work as a principal product manager in the core EC2 instance team. And today I'm joined by Vijay. He works as a software engineering principal architect. He's from Salesforce. And together we are super excited to be talking about the AWS Nitro System, the underlying technology using which our modern instances are built. So if you're looking to get an idea of what an AWS Nitro System is, what are the benefits of AWS Nitro System, and the innovations it has allowed us to achieve over the years and years, then you would like this session. If you want to understand the new instances that we have launched, specifically the Gen 7 instances that we have launched using the AWS Nitro System, then you would love this session. And finally, if you want to know how Salesforce, our customer, has been able to leverage our instances to get performance benefits, then you would get a valuable information from Vijay in this session. So without any further delay, let's get started. So Nitro has had a huge impact on EC2 and on AWS. Today, majority of our fleet is based off Nitro System. So we introduced Nitro way back in 2017, but the actual work related to Nitro started almost a decade back. And when we talk about the Nitro System, we often talk about a single entity object or an abstract object, right? But what are the components of the Nitro System? My goal is to break down the Nitro System into different components and talk about each of those components in detail. So if the image that you see on the slide is an image of an instance stack. The top three parts are what is there in a server. So you would see a customer application in there, the instance OS, and also a lightweight Nitro hypervisor. And the bottom part is what is the Nitro System. It's a dedicated hardware which for security, storage, or networking functionalities. So when someone asks you what is a Nitro System, you can say that Nitro System is a lightweight hypervisor and a dedicated hardware which is used for security, storage, and many other functionalities. But before I dive into each of those components of Nitro System, let's take a look at what was the motivation behind creating that Nitro System. So when AWS first started, we used state-of-art hardware and software at that time to architect the cloud, very similar to the on-premises data centers that we have. But one problem that we encountered was that the system hypervisor was consuming too many compute resources, including the vCPU and memory. There were also performance variations in the EC2 software stack, which was partly caused by the increase in the customer demand, but it also hinted at a possibility of problems which could come in future. So AWS realized that we need to do something different, and this something different led to what we call our hero, which is the AWS Nitro System. So essentially, we are trying to solve three key problems with Nitro System. One is to reduce the hypervisor tax so that we can give you the compute resources. Two, to limit the performance variation. And thirdly, to have a system which will have a foundation for all of our EC2 instances. So this required a large departure from classic virtualization technologies intended for an on-prem usage and reimagining of how it will look like in the cloud. So to understand that, I want you to look at this slide. And in this slide, you would see a classic virtualization diagram. It's a diagram of a host. You would see the square boxes in the host are where the customer instances are living. And then you would see that networking, storage, management, security, and monitoring functioning, along with hypervisor, is there in the host itself. Now, if you look at the diagram for AWS Nitro System, you would see that we have ported over all the functionalities, the networking, storage, management, security, monitoring, all to dedicated hardware. And even the hypervisor is a very thin hypervisor, and we have purposely kept it thin. We will dive deep in the next slide. So if we dive one level deep into different components, then at high level, I would say that there are three different components of the Nitro System. the Nitro cards, the Nitro security chip, and the Nitro hypervisor. The Nitro cards and the Nitro security chip are the hardware-based components, whereas Nitro hypervisor is a software-based component. So let's take a look at what are the different Nitro cards that we have used. So there are different type of Nitro cards for networking, elastic block storage, and the local instance storage. And you can map them or try to relate them through the instance features or the instances that we have offered. For example, the VPC networking card can be mapped to the networking bandwidth that we offer with our instances. The EBS, the elastic block storage card, could be mapped to the EBS bandwidth that we offer with our instances, whereas the local NVMe storage can be mapped to the disk-based instances that we have. But there is also another card, which is the behind-the-scene card, which we call as Nitro Controller. Nitro Controller is the brain of the system. So it interfaces with the EC2 control plane at one end, and it coordinates with the other cards, including the Nitro security chip and the Nitro hypervisor. Now, Nitro security chip is something which is integrated into the motherboard itself and is responsible for protection and integrity monitoring of the hardware resources. Let's take an example to understand this better. So any server would have different hardware components like memory DIMMs or microcontroller to keep a track of temperature. And each of them would be running some form of a firmware. And this firmware needs to be updated for new enhancements or to fix bugs or any other reasons, right? Typically, what you would do is you would log onto the host and use a tool to flash the firmware updates. And since customers are already running on the host, there may be a chance that customer could get to those spy flashes, but not with Nitro. We have a dedicated hardware to update the firmware flashes, and no one can muck with the spy flashes. So this makes running your instance secure in the Nitro environment. The last component is the Nitro hypervisor. So we have intentionally kept it very, very thin. So the one thing that it does is it programs the hardware for virtualization to carve the vCPU and memory, and hypervisor only talks to the Nitro controller. It stays quiet when the instance is running. The goal was to get the Nitro hypervisor performance to be the same as the bare metal performance. So just by a quick show of hands, how many of you have heard about the bare metal instances? I think majority of them have heard about the bare metal. So the bare metal instances are the instances where there is no hypervisor involved. You get a direct access to the hardware. And we'll talk in more depth about these bare metal instances. And Ravi would, Vijay would also give an example of the bare metal instances performance comparison with the virtualized instances. So enough of looking at the symbolic representation of what a Nitro looks like. Let's take a look at what the Nitro system looks like under the hood. It's hard to believe that some of these cards are actually a building block for our cloud. So these are the cards which are the brainchild of Annapurna Labs, which is now a part of Amazon. And it's the underlying foundation upon which our modern EC2 instances are built. And these cards, if you look at these cards, they look very similar to the network interface card. And over the years, we have developed the newer cards with each generation of instances that we have launched. Now, as a customer, you would say that, okay, AWS has created a great framework, but what lies in for me? What are the benefits of AWS Nitro System? So there are three essential benefits for AWS Nitro System: the performance, security, and the innovation. The first obvious benefit of performance is that because we are offloading all the networking, EBS, and storage functionality to dedicated cards, you get in more vCPUs, you get in more memory, you get all the compute resources. So obviously, you get more performance. And the second benefit related to performance is that you get, when you're running a real-world workload, for example, customers have told us that they run Memcached or NGNX or FFmpeg or X264 to run or to stress out the system and run and compare the system level performance. And when they run real world workloads on EC2 instances and compare it to the other cloud providers, they typically see higher performance on EC2 instances. It is because of Nitro. And lastly, the Nitro also gives us a capability to scale the networking and EBS bandwidth. And I would talk in a bit more detail in the subsequent slide about how we have been able to scale the networking and EBS bandwidth using Nitro. The next benefit is the enhanced security that monitors, protects, and verifies the instance hardware and firmware. So I spoke about the Nitro security card in my previous slide, but there are also details available in a white paper that we published last year, and I would encourage you to look at the white paper. I have provided the link as well as the barcode related to that white paper. The third obvious benefit and the biggest benefit is the pace of innovation. Nitro allows us to accelerate the pace of innovation. Think of it this way. You have a CPU which you qualify, and then different Nitro cards which are already existing. Just like a Lego block, you can use the CPU and connect different Nitro cards to come up with different instances. Isn't that amazing? This is especially important in the rapidly changing environment that we live in. If our customer comes up with some kind of a new requirement, then we are able to meet their requirements quickly at a higher quality bar. Super important. Now let's dive deep into the performance angle and the innovation angle in here, and let's start by talking about the Nitro performance with networking bandwidth. So when we first launched our first instance, the M1 base instance, at that point, we provided a networking bandwidth of 1 Gbps, which at that time was sufficient. But then, as customers started bringing in more workloads from on-prem to AWS, they started asking for more networking bandwidth. So in 2013, what we did was, we started offloading, and this is where the Nitro journey actually began. That's why I said almost a decade back. We started offloading the networking functionality to a dedicated card. And we were able to achieve a networking bandwidth of 10 Gbps. And in subsequent generations, we have been able to increase that networking bandwidth. So for example, for our Gen 5 instances, the C5s and M5s instances, we provide a networking bandwidth of about 25 Gbps. And for our Gen 6 and Gen 7 instances, we provide networking bandwidth of about 50 Gbps. The customers then said that there are more demanding workloads like network appliances or telco workloads, the AI/ML workloads, the HPC-based workloads, and you need even higher networking bandwidth. So what we did was, we used series of networking cards to deliver even higher networking bandwidth. So either we used a dedicated card for networking, or we used series of cards for delivering higher networking bandwidth. And if you attended Adam's keynote yesterday or Dave Brown's session, then you would have seen that we are able to support networking bandwidth of 6400 Gbps, simply unheard of, which will be through our Trainium-based instances, which would be coming out soon. Let's take a look at EBS bandwidth. Now, once our experiment related to offloading the networking functionalities to a dedicated hardware was successful, the next thing in 2015 we did was, we offloaded the EBS related functionality to a dedicated card. So instantly, we were able to increase the EBS bandwidth from 2 Gbps to 4 Gbps, and we were even able to double the IOPS. And over the period of time, as we came up with the new versions of Nitro card, we have been able to scale and increase the EBS bandwidth. For example, with our Gen 5 instances, we were able to support EBS bandwidth of about 19 Gbps. And with our Gen 6 and Gen 7 instances, we were able to support EBS bandwidth even higher, about 40 Gbps. Now, the customer said that, or said to us that they have more demanding workloads like file system or even databases workload, and they need even higher EBS bandwidth. So because we had Nitro system, we were able to scale even the EBS bandwidth to 60 Gbps first, with R5B instances that we launched before in 2020, and then with our C6IN, M6IN, R6IN, M6IDN and R6IDN instances, which was announced or which was launched in last reInvent, we were able to support EBS bandwidth of 80 Gbps and 350K IOPS as well. Now, but just with a few changes to the Nitro card, this year, what we did was we just increased the EBS bandwidth from 80 to 100 Gbps, and we were also able to scale the IOPS from 350K IOPS to 400K IOPS. And all of this is possible because we had Nitro System. Now, let's talk about the innovation angle in here. So, I would like you to look at the chart in a manner that post 2017, it's a Nitro era, and before 2017, it's a pre-Nitro era. So pre-Nitro era, from 2006 to 2017, before we launched Nitro instance, we were able to ship 70 instance types. And when I talk about instance types, M5.large is one instance type, M5.xlarge is another instance type or instance configuration. Right? And when I just talk about instances, then M6I is an instance, M5 is an instance. But from 2017 to 2023, we have been able to support more than 750 instance types. And it is possible because we have Nitro System. That's the only change we made from 2006 to 2017, and the biggest change we made from 2017 to 2023. Not only that, if you look at your chart post 2017, then you would see that every year we had some kind of new technology coming up. For example, in 2018, we launched our first ARM-based instances using Graviton. 2020, we launched Graviton 2-based instances. We had our Nitro SSDs, our Trainium-based instances launched as well. The world is talking about the AI ML in 2023, but we launched an inference-based chip in 2019 itself through our Inf1 instances. And this year, we even refreshed our Inf1 instances with Inf2. So all of this has been possible because we have an ability to innovate faster because of Nitro System. And we have also been able to innovate across the different CPU processor families. So pre-Nitro era, before 2018, we had instances with Intel processors. And after that, in 2018, we were the first cloud provider to offer AMD-based instances. We were also the first cloud provider to offer the ARM-based instances in cloud using our own Graviton chip. And we were also the first cloud provider and the only cloud provider so far to offer the Mac-based chips or Mac-based instances. So you would see a lot of first here. It is because of the foundational Nitro technologies that we have been using. Because of Nitro, we have been able to deliver the right compute for each application and workloads. And we have been able to offer different broad choices of instances using different processors and architectures to our customers. So we recently launched the Gen 7 instances across different swim lanes. And thanks to Nitro, we have been able to deliver 17 plus EC2 instances. Now, when I talk about instances, in this case, M7i is one instance, M7i Flex is another instance, not instance type. So just note that distinction. Let's look at the instances that we have offered in the past year and a half or so. So we started the Gen 7 journey with Graviton 3-based instances. We launched C7G instances and then M7 and R7G instances. These instances provided up to 25% higher compute performance and 2 times higher floating point performance to accelerate most compute-intensive workloads. These were the first instances in cloud to support the DDR5 memory, which provided 50% more memory bandwidth over the DDR4 memory DIMMs that we had. And these instances could also be used for AI and ML workloads because they provide up to 3 times higher performance for machine learning workloads, 2 times higher vector width, and also support for bfloat16 data type. There are also PyTorch and TensorFlow optimizations, which could help with the AI ML workloads. So we launched C7G, like our compute optimized instances, general purpose instances, memory optimized instances, along with the disk variants. We also launched our high networking variant of Graviton 3 based instances. And then we also, for the very first time, launched our HPC-based Graviton 3 based instances. So we launched so many instances using the Graviton 3 processor in the past year or so. And if you think that is impressive, then be ready to be impressed even more. Because yesterday, if you would have attended Adam's keynote, then he announced the Graviton 4 based instances. So we launched the Graviton 4 based chips and R8G as our first Graviton 4 based instances. These instances provide up to 30% better compute performance compared to the previous generation R7G instances. And they provide memory up to 1.5 terabyte, 3 times higher versus the previous generation R6G instances, which is suitable for scaling if you have some kind of a high performance database workloads. And these are the most energy efficient instances in EC2. Now, all of these have been possible because of the Nitro, but there is a customer angle in here as well. Like, what has our customers said about our instances? Let's take a look at what our customers are talking about our Graviton instances. So customers like Sprinkler have been able to leverage C7G instance and provide 27% better performance versus C6G instances. Whereas customers like Nextroll have been able to get 15% higher request handle with C7G instances and 40% higher latency versus the previous generation C6G instances. Whereas customer like Honeycomb has 100% of their EC2 fleet using Graviton. And with C7G instances, because of the performance of C7G instances, they have been able to consolidate their workloads, and they have been able to use 30% fewer instances and save massive costs versus the C6G instances for the same workloads. Whereas the customer like Telium have been able to use our high networking variant of C7G and of C7G instances and get 29% better performance for their real-time workload management application. So the meta theme in here is that Graviton instances have saved cost for our customers, and their customers are getting the best price performance on Graviton-based instances. Next, I would like to talk about the innovation across the Intel swim lane. So AWS has been partnering with Intel since past 17 years, the longest of any cloud vendor. Now, in this partnership, the AWS and Intel's leadership team, the engineering teams, and many other cross-functional teams have been engaged ever since AWS launched its first EC2 instance in 2006. And in those 17 years of collaboration, AWS has introduced more than 400 different Intel-based instances. And since August, we have launched more than 5 different Sapphire Rapid-based instances. Let's take a look at what we have been able to offer with our Sapphire Rapid-based instances. So I want you to focus on the innovation pillar first and look at the processors. These aren't any roadmap processors from Intel. These are custom processors. So AWS has partnered with Intel to have a custom processors available only to AWS. So if you have an EC2 Nitro system and then you have custom processor, it means that our Gen 7 Intel instances would be able to deliver 15% better performance versus other cloud providers using comparable Intel processors. Isn't that amazing? The good news is that the innovation doesn't end here. Traditionally, EC2 instances were probably offered with a single bare metal size. But starting with Gen 7, for the very first time, we are offering 2 bare metal sizes with our Intel instances. And each of these bare metal sizes would support the discrete on-device accelerators that comes with the Intel chips. So there are 3 discrete on-device accelerators, the QAT, the DSA, and IA, and these would be supported on these bare metal sizes. So if you have a workload which is related to compression or encryption or databases workload, then you would benefit from these accelerators. Our Gen 7 Intel-based instances have been able to provide up to 19% better price performance versus the previous generation Ice Lake-based instances. And there are many new features and offerings with our Intel-based instances. There are different flavors of instances, first of all. The M7i Flex is a new category of instances which we just introduced, and I'll talk about it in a moment. We also announced the preview for U7i instances, which offers up to 32 terabytes of memory. And then there is a fastest Sapphire Rapid-based processor instance in cloud, the R7iz instances. With our Intel-based instances, we support the DDR5 memory DIMMs. They support sizes up to 48x large, and we have increased our EBS volume attachment from 28 to 128. There is also an ISA-based AMX instructions which are supported with our Intel-based instances. So if you have some kind of an entry-level AI/ML workload, right, you can consider using Gen 7 Intel instances. And then you can, if you have very simple LLM models and you're just starting your journey with AI/ML, then you can use these instruction sets which comes with the Intel processor. And then you can gradually transition to the GPU-based instances once your model becomes more complicated. Now, the two different things in those slides, and the two new innovations in those slides were M7i Flex, which is a new category of instances, different from our C's and M's and R instances, like C7i and M7i and R7i instances, and the dual bare metal or the two bare metal sizes, right? So when we were designing the Gen 7 Intel instances, we realized that the customers do not fully utilize the compute resources of the EC2 instances. Yet they were paying for the CPUs that they were not utilizing. And last year, you all know that cost optimization was the theme. And our customers were asking us to give them the latest and greatest without increasing the price. This led to the innovation of new category of instances, which we called as M7i Flex. So M7i Flex are the easiest way to get the price performance benefit for majority of the general purpose workloads. So if you have any kind of web serving workloads or virtual desktop workloads or other general purpose workloads, you can consider using M7i Flex. They offer up to 19% better price performance versus the previous generation Ice Lake-based instances. And they are available in most common sizes, from large to 8x large, which means you will get up to 32 vCPUs to 128 GB of memory. They are the ideal first choice for most of the applications that do not utilize all the compute resources. So if you have some kind of other application which utilizes compute resources, like some kind of a financial trading application, then don't panic. We have M7i instances, you can use them. But for all the other general purpose workload, you can use M7i Flex. Now, M7i Flex was possible, and we were able to deliver it quickly because we had Nitro System. So there is a new Flex CPU scheduler which was built as a part of the Nitro System. The Nitro hypervisor runs this new Flex CPU scheduler, which ensures that at a server level, the M7i Flex instances get the CPUs that they need instantly. Also encompassing our Nitro System and Nitro hypervisor, we also had Nitro management services comprising of intelligent placement and live migration that ensures that M7i Flex instances gets the CPU that they need instantly by leveraging the servers across the EC2 fleet. So net, we see that AWS Nitro System kind of allowed us to enable the M7i Flex instances, and it allowed us to get the CPU resources that they need within the server, as well as across the server, to deliver reliable and consistent performance. Let's talk about the Gen 7 Intel bare metal instances. So in 2017, our customers actually told us that they have some legacy workload wherein they cannot use hypervisor. They have some licensing database workloads wherein they cannot use the hypervisor. They needed direct access to the bare metal or to the hardware. And because we had AWS Nitro System, and remember from my previous slide, we intentionally kept it very thin, we were able to chuck off the Nitro System, the hypervisor, and provide our customers with the bare metal instances. So we launched the I-based bare metal instances for the very first time in 2017. But what happened after that, like with each instance that we were launching, we were having bare metal instances, which was the largest size, typically the largest size. As we were moving we refreshing our newer, going to a newer generation, the CPU vendors were also increasing their core counts. For example, our Cascade Lake processors were 24 core, our Sapphire Rapid processor is 48 core. And a customer said that they wanted smaller bare metal sizes because they were already using the Cascade Lake processors and they want to transition smoothly using the smaller bare metal sizes. There were also customers like NASDAQ who wanted better NUMA affinity or a single socket bare metal sizes. And that's why we decided to launch 2 bare metal sizes for the very first time with our Gen 7 Intel-based instances. And this was all, again, possible because of the Nitro system. Let's take a look at what our customers have been telling about the Gen 7 Intel instances. So customers like Salesforce have been able to get up to 25% higher throughput at 11% faster response time on M7i versus M6i. So Vijay would talk more about these performance numbers in the next few slides. The customers like NASDAQ have been able to simplify their NUMA architecture and leverage our smaller bare metal sizes for their financial application workloads. Whereas the healthcare customer like Tufts Medicine have been able to saw 3 times more users per session and 68% higher performance on M7i versus M5n instances. Then customers like Astera Labs have been able to use our R7iz instances, the fastest Sapphire Rapid instance on cloud, and able to get 25% better performance versus the R6i instances for their EDA workloads. So the meta point in here is that it's fascinating to see that there are workloads across different industries where customers are able to leverage our Gen 7 Intel instances. I do want to switch gears and talk about our Gen 7 Genoa-based instances as well. So in 2018, we were the first cloud provider to offer the instances with AMD processors. So we positioned the AMD-based instances and priced them 10% cheaper versus the corresponding x86-based instances. We continued with this positioning in Gen 6 AMD-based instances as well, which allowed customers to save cost. But we realized with Genoa that AMD has made significant advances in their core counts. They were offering cores up to 96 core. And our customers were also asking us for higher performance. So what we decided to do with our Genoa-based instances, we decided to disable hyperthreading. And by that, I mean that we offer 1 vCPU as 1 physical core. Typically, we have been offering 2 vCPUs as 1 core. And because of that, we were able to deliver disruptive performance improvement of up to 50% versus the Gen 6 AMD-based instances. Now, because the AMD-based instances are also using the Nitro system, they are using the same components essentially as the instances built using the other CPU processors. This means that the customers could migrate to AMD-based instances with little or essentially no code modification. And in terms of feature, our AMD-based instances were built using the DDR5 memory DIMMs. They have a new medium size. They also have AVX5112 VNNI instructions enabled. These were not available in Gen 6. These are available only in Gen 7. And there is also a support for bfloat 16. And as our Intel-based instances, these instances have increased EBS volume attachment of up to 128. Let's see what our customers are saying about our AMD-based instances. So customers like Netflix, who have tried out our AMD-based instances, observed 40% throughput improvement and 50% latency reduction with our AMD-based instances, with M7A instances specifically, versus the previous generation. Whereas the customers like Ferrari have been able to use HPC 7A instances and get 30% performance improvement for their computational fluid dynamics workload, or CFD workloads, and 25% performance improvement for their finite element analysis workloads. There are customers like Total CAE and Aconia who have been able to leverage our AMD-based instances and gotten and either used our AMD-based instances for the higher networking bandwidth, or they have used AMD-based instances to reduce their simulation times. So the meta point in here is that if the customers are looking for higher performance, or if they are looking to get their jobs done sooner, then they are considering our Gen 7 AMD-based instances. I think now that you have heard from an insider, like how AWS have been able to leverage the Nitro-based instances, Nitro-based system and create many instances, I would like to pass on the stage to Vijay, who would talk about how Salesforce, one of our top customers, have been able to leverage the Nitro-based instances and get performance improvements. What do you, Vijay?
Thank you, Sudeep. Hello, everyone. My name is Vijay Pula. I'm from Salesforce. And Salesforce is the pioneer in the software as a service model right from 1999. And it is currently one of the largest enterprise software company in the world. And as you heard yesterday from Adam's keynote, AWS and Salesforce are extending the relationship to the next level. And currently, AWS is the primary cloud provider for Salesforce. So I'm excited to be here to talk about how we leverage the EC2 instances for our fleet-wide workloads in Salesforce. So before I proceed, so here's a standard disclaimer that we usually put in any talk that Salesforce delivers. So as you probably are already aware, any performance numbers are have a huge variance based on like the workload types and what kind of test configurations and environments and all the different tunables that you have in the stack, how you have set it and so on. So the gist of the message here is please don't make any purchasing decisions based on the results I'm going to be sharing here. Okay. So having said that, let's start with a quick overview of the Salesforce Einstein 1 platform. And for those of you who don't know about it, it is the world's #1 AI CRM platform. And in this platform, we have, like you see on the left side of the picture, Data Cloud and Einstein AI. Both of them are native to the Einstein AI platform. And with this platform, our customers can enhance and seamlessly align their CRM applications and using the integrated metadata, using that metadata framework that you see at the bottom of the picture. And you can generate code, content, emails, campaigns, and a lot more with intelligent builders. And you can automate securely across people, processes, and systems to increase the productivity. And you can use low-code and no-code tools to drive dev and admin efficiency. And you can extend Salesforce faster with the open APIs and thousands of ecosystem partners that we have in the Salesforce ecosystem. And to learn more, I have put a QR code on the slide. You can scan that and it will take you to the page where you can learn more about this platform. And so to summarize, with the Salesforce Einstein 1 platform, our customers can easily create AI-powered applications and workflows that supercharges productivity, it reduces costs, and it delivers amazing and trusted customer experiences, all powered by the data, AI, and CRM. And this platform has a massive scale. Like across, we serve tens of millions of users on a daily basis across many industries and across many geographies. So on a daily basis, we process over 3 billion transactions with an average response time of under 300 milliseconds. So now let's go to the, now that we have seen what the high-level overview of the Salesforce product stack, now let's talk about the Salesforce Hyperforce. So if you have been already using Salesforce products and services, or if you have been following Salesforce's announcements, you probably already have heard this term called Hyperforce. So let's look at what is Hyperforce. So Hyperforce is the next generation Salesforce's infrastructure architecture that is engineered for the public cloud. And With this, and if you want to learn more about Hyperforce, again, I have put a QR code here that you can scan, and it will take you to the page that has tons of information on Hyperforce. But there are some key differentiators with Hyperforce as compared to our competitors. So as a customer on Hyperforce, you can manage your data residency. You can choose where on the Hyperforce you want to run your Salesforce applications. You can assign local storage, and you can also offer several compliance certifications that local region requires. And as a customer on Hyperforce, you can scale sustainably by serving your customers fast with a flexible and scalable infrastructure that is delivered on a carbon neutral cloud. And on Hyperforce, you get a deeper level of security because we enable end-to-end data encryption by default. So that includes data at rest and also the data that is in transit. And with Hyperforce, you can also safeguard customer data using the robust and transparent privacy controls. You'll know exactly what customer data is being collected, who has access to it, and how it is being used. And with Hyperforce, you can also increase, as a customer, you can increase your agility by reducing the time to value, work faster, using the zero downtime upgrades that Salesforce delivers on Hyperforce. And also there's extensive native public cloud integrations with several other products and services that AWS offers and also other clouds offer. So in a nutshell, using on Hyperforce, basically our customers can scale globally across a lot of different regions where Hyperforce is available, but at the same time, they're serving their customers locally in that region, right? And so now let's look at how Hyperforce is on AWS. So Hyperforce by design is multi-substrate, which means in addition to AWS, we do work with a few other cloud providers. But as of now, AWS is our primary cloud provider. So the map that you see here, like I have overlaid the AWS's global infrastructure map, showing all the regions where Hyperforce is currently live and serving production traffic with live customers on it. And as you can see, there are about 18 AWS regions where Hyperforce is currently live. And there are a couple of other regions where we are in the process of deploying Hyperforce and going through all the different compliance validations before we open it up for our customers. So as we speak, there are more regions that we are going into on AWS. And so Hyperforce's design and implementation, it perfectly aligns with all the 6 pillars of the AWS's well-architected framework. So you can rest assured that it is highly available, it is secured, and it is reliable, and so on. Okay, and so Hyperforce basically is engineered such that our customers can increase growth in new regions. They can expand their growth into new regions. They can improve their regional performance. They can handle the mission-critical workloads, and they can receive the latest and greatest from Salesforce with a lot of speed. So now let's look at, now that we have seen the Salesforce's overview and then the Hyperforce and what Hyperforce is on AWS. So let's look at the compute that we use in Hyperforce on AWS. So of course, in addition to compute, we do consume tons of other AWS's products and services. But since this is about the Nitro system, we will keep this discussion focused on EC2. Just like any enterprise and mission-critical systems, so under the hood, Hyperforce in AWS is also a very distributed ecosystem. It is service-oriented with a lot of microservices, and there's a wide range of technologies that we use across the different subsystems in our overall ecosystem. So we carefully choose a given technology based on what is best suited for a given subsystem based on the task at hand. And so in a nutshell, we have a wide variety of workloads, with each of which has like different characteristics of its own. And as you heard from Sudeep, AWS has been innovating so fast. Like they have been releasing like 172 plus instance types. So how do you even keep up with all of this, right? How do you know what is the best instance type that we should be picking up for a given workload, right? So in Salesforce, the process is as follows. At a very high level, so basically we do have ongoing discussions with AWS and our awesome technology partners in Intel and AMD to understand what is the next processor that the chip vendors are coming up with, and when AWS is going to be taking that and then translating it into an instance type that will be available for us. And to understand what are the benefits or what are the advantages of the upcoming newer processors and how we can leverage that, right? So that is one part of the equation. Then the other one is we look at something called as an instance recommender tool, where basically we point it to our production systems or our pre-production systems where we have all kinds of workloads that are mixed together. And basically the instance recommender runs through all the different types of instances that we will pick as a subset, and then it kind of gives us a list of recommendations. And then we also look at any industry standard benchmarks if they're already available. And if not, then we do run industry standard benchmarks as well. And based on that, and then of course we do look at the price performance ratios because we would like to keep optimize for the cost as well while making sure that we deliver trust and performance to our customers. So once we understand all of this, then we shortlist a few instances that we would like to experiment with, and that is when it comes to my lab. And we basically run a series of workloads that are specific to Salesforce, some of which I'll explain it in the next slide. And based on the benchmark results, we basically then work again with AWS and Intel or AMD, depending on which instance type we are picking, to understand what are the supply logistics. Like because Hyperforce is spread across so many regions, but we don't always have the latest and the greatest instance types available across the board. So we do take that into consideration, and then we prepare our rollout plans where we have a very strict stagger in terms of how we deploy the new instance types to our production fleet. And of course, we do deploy it in such a way that it goes to our pre-prod environments first. We have a bake period to see if there are any issues that we may find, and then also after that we deliver it to. So we have like our own engineering org in one of the Hyperforce instance. So anything that engineering is confident of delivering, we first put it there. So if something breaks, like the whole engineering team, like thousands of engineers, they're all experiencing downtime. So we basically take it there. Once we are confident with the pre-prod environments, we put it there, we let it bake, and then we take it to another instance where we have internal Salesforce orgs and internal Salesforce customers across the different divisions. We make sure that it works fine before we take it to our production systems where we have live customers, right? And even there we do it in a staggered manner, and we closely observe. We have like a huge amount of metrics that are emitted from across the stack from different subsystems, and all of that is basically we have monitoring and alerting in place to make sure that nothing breaks. So, and also because of the way how the Nitro system is designed that Sudeep explained so beautifully, so there is a very quick turnaround. Like most of the time we see that the moment Intel announces a new chip or AMD announces a new chip, to the time when it is available for assessment in my lab, the turnaround time is very quick. And that is purely possible because of the Nitro system that AWS has. So now moving on, so before I go to the next slide, I would like to quickly explain to you like a little more details of how we do the benchmarks, right? So we do have like synthetic benchmarks that we run in my lab, and we basically prepare something that we call it as a composite workload. So composite workload basically is a mixture of several different scenarios that we see in production. So we pick the top few most commonly used scenarios, and then also we pick the top few most critical scenarios. Like for example, login, it is not one of the top commonly used scenario, but it's the most critical. So we do pick the critical scenarios as well, and then we pick a mix of scenarios that exercises the different subsystems of our target SUT that we would like to exercise and to the intended load. right? So that's how we prepare the composite workload, and then we have the load shape where we try to simulate like typical peak production loads and things like that. And also we have some other types of tests where we do overload and stress tests and things like that. And in addition to that, then data set is a very important component of any benchmark, at least for the Salesforce, and I'm assuming for most other applications as well. So the data, when we say data shape, it's not only about the data volumes, it's also about the data complexity and how all these different entities relate to each other, the complexity of the data set, and some of the customizations. Because Salesforce platform is highly customizable, our customers kind of do all kind of customization on top. So we do pick a few of those as a representative scenarios. So that's how we run our benchmarks. And what you see here on the screen is basically how those synthetic benchmarks have been behaving across all the different instance types. So we started off with, and again, remember here that the application, this particular application is a Java-based application, and it is deployed on Kubernetes. It's a containerized application that is deployed on Kubernetes. So across the tests, the resource spec of a given Kubernetes pod and all the containers inside that, they're all fixed, right? Nothing is changing. And similarly, the number of kpods that application is getting for a given test is also fixed, right? And similarly, the release, the load shape, the data shape, and all the other test parameters that I mentioned earlier, they're all constant, okay? So the only thing that changes is the underlying EC2 instance type, right, that we would like to experiment with. So the far left data point, the first data point that you see is the M512XL, and that is the instance type that Hyperforce started with. Like that was the instance type that we were running fleet-wide across our entire Hyperforce instances. And at some point, we basically decided to vertically scale the instance size, right? So we were still in M5, but then we were quickly finding, because of the massive migrations that we were doing from our first-party data centers to the Hyperforce instances, we were kind of had this pattern where we keep adding more and more nodes to our clusters. So at some point, we basically vertically increased the instance size from M5.12 to M5.24XL so that we get more resource spec for the same number of nodes in our clusters. And at that point, of course, we again did an detailed assessment in the lab. And so as you can see here, basically there are two plots. The one in the blue is tracking the throughput or the capacity, and then the one in the green is our response times. And the blue one is mapped to the axis on the left, and the green one is mapped to the axis on the right. So as you can see, when we went from the M5.12XL to M5.24XL, so the workload throughput that we're getting is on par, right? Now, if you're asking, hey, you just double the instance size, why is your throughput still the same? You have to remember what I said earlier, is the resource spec per kpod, per Kubernetes pod, and the number of kpods that we allocate for that application is the same, right? The only thing that has changed is the underlying instance type. And then the instance type, previously when it was running M5.12XL, it was packed with a certain number of pods, and now Kubernetes pods, and now with 24XL, it is more densely packed, right? So, but then at the throughput level, we are still getting on-par throughput. Yes, the response time slightly degraded, but then it was still well within our acceptable range. And now, so this is again, it's showing that when you vertically scale the instance size, because of the way how Nitro system is designed and implemented, there's no side effects, right? You can play around with the different instance sizes. But of course, you have to remember other factors. If you are on Kubernetes, like for example, what is your bin packing efficiencies, and what is the amount of total unallocated resources and things like that you have to be paying attention to, because that does impact your costs, right? And then at some point when M6i became available, we did again a series of assessments in the lab, and then we rolled it out into production, and we did hit a glitch where we worked with our Intel technology partners to eventually nail down that issue and resolve it. But then, as you can see here, the throughput has increased and the response times have reduced, which is good, right? You want lower response time and higher throughput. And similarly, now we are evaluating, this is the latest from our lab, the M7i.24XL. And as you can see here, when you compare the M7i.24XL with the M6i, so the throughput has increased by 25%, and the response times have reduced by 11%, which means it has become faster by 11%, which is a great trend to have. And we see the same trend even on the AMD. Some of the production instances that we have is running on AMD. So when we compared with M6A and M7A.24XLs, we noticed like 40% higher throughput and 19% faster response times on M7A as compared to M6A. So now, for translating, how do you translate this into the cost savings? That's a whole other topic for maybe some other day. But that's from the performance angle. So now, let's talk about the performance in the bare metal instances, right? Like as Sudeep was mentioning, the difference between the bare metal and the VM, right, is that the bare metal does not have the hypervisor, right? And the equivalent VM will have the hypervisor, but both of them have the same resource spec. So now, when AWS launched the M5 Metal, we were very curious to you always have that itch, right, performance engineers. So we wanted to measure and find out, hey, is the hypervisor really lightweight and has absolutely no impact? So we did run a bunch of the industry standard spec CPU 2017 test suite benchmarks. And what we found is that the M5.24XL and the equivalent M5.Metal had very similar performance characteristics, right? It was within 1.5 to 2%, which is well within the error margin. So it was on par, right? And then similarly, when you go and experiment with the M7i 48XL with the equivalent M7i 48XL Metal, we again found a very similar trend that both of them shows about the on-par performance. So that basically is another data point to support what Sudeep was saying about that the hypervisor is so light that it really does not have any performance over it. So with that, here's back to Sudeep.
I think we just have the last slide. So the key takeaways in here is that AWS has a unique differentiator in terms of AWS Nitro System. We have it since 2017. Some of the other cloud vendors have just started. It has allowed us to innovate faster on behalf of our customers and deliver better performance and security versus other cloud provider. We launched the EC2 Gen 7 instances using the Nitro processors, using the Nitro system, and we have been able to launch 17 plus new instances across different CPU options with many new features. And lastly, the AWS Nitro system has allowed the partners such as Salesforce to take advantage of the infrastructure that continuously improves. So with that, I think we would like to conclude our presentation. And please do fill out the survey, which is there in the mobile app. And if you have any questions or would like to contact us, then we have provided our email IDs as well.